Hi friends, myself Lakshmi. Today I want to explain some of the nuclear characteristics. That is, conservation laws in the nuclear reactions is they are conserved in the conservation of energies. Both product and reactants having an energy remains constant in the for nuclear reactions. Next, conservation of charge. Total charge in all types of nuclear reactions will be conserved, means constant. Next, conservation of linear momentum. So total nuclear reactions linear momentum will be conserved or constant. Next, conservation of angular momentum will be holds good. Total nuclear reactions total angular momentum will be conserved. Next, conservation of parity. Parity is also conserved in the nuclear reactions. So conservation of nucleons. Total number of nucleons present in the reactions will be conserved. Next, conservation of mass number. The mass number of the product and reactants will be conserved. Next, conservation of spin. Total spin of the reaction. In case of the nuclear reaction, product and reactants will be conserved. Next, liquid rock model of the nucleus. It explains the constant density R is proportional to a to the power of 1 by 3. That means radius will be proportional to mass to the power of 1 by 3. Next, it depends on the neutron excess number of n minus z on a to the power of 5 by 3 in stable nucleides. And it also explains the stability limit for the heavy nuclei. Approximately constant binding energy per nucleon. Binding energy per nucleon means packing fraction. Next, beta decay properties will explain the liquid rock model. Nuclear fission reaction and nuclear reactions will be explained in the liquid rock model of the nucleus. Next, in the nuclear forces, some of the characteristics should be conserved. Explained. There are nuclear forces are strongly attractive in nature. Nuclear forces are strongly attractive in nature. That means nuclear forces between the nucleons is very strongly attractive, is more stronger than the magnetic forces and 10 power 21 times stronger than the electrostatic forces and 10 power 38 times stronger than the gravitational forces. Next, nuclear forces are the short range forces and its range becomes 10 power minus 15 meter, that is Fermi. Next, nuclear forces are strongest in for all forces. For all forces means gravitational forces, electromagnetic forces, etc. Nuclear force will be more strong. Next, nuclear forces are saturated forces. That means binding energy per nucleon is nearly constant for all nuclei except for the atomic number less than 20. So greater than 20 atomic number will obtain at the binding energy per nucleon is nearly constant values. Binding energy per nucleon means packing fraction. Next, nuclear forces are charge independent. Strength and nature of the nuclear forces exist between the nucleons. So proton-proton interaction, neutron-neutron and proton-neutron interaction strength will be depending on the nuclear forces. So next, spin dependent. Spin of the orientation of the two nucleons will be dependent on the nuclear forces. So they are in triplet state, that is spin is parallel condition 3s1 state, and singlet state spin will be becomes an anti-parallel 1s0. They are more strong in nuclear forces. Thank you.